Okay, here's another direct current circuit, which is a solenoid. In this case, an injector could be. But it's on pulse width, the on time, or the duty cycle electrical signal. Now look at this here. This is my voltage, system voltage, probably 13 to 14 volts. It's ground controlled, so it's being turned on here, pulled towards ground. So this side's the ground circuit, probably within 50 millivolts of ground. And it's being turned off. We get the spike and back down close to system voltage again. Now this could be an injector, it could be a purge solenoid, but it's a solenoid. The pulse width is from here to here. See, it says here 3.1 milliseconds. That's the time it turned on to the term it turns off. That's your pulse width. On versus off. The amount of time is on. Now the difference is, if you have a fuel injector, this is the amount of time that the fuel is being sprayed into the combustion chamber, right? And it's continuously changing with engine speed. That's your pulse width, right? It changes with engine speed. Duty cycle remains fixed. If there's a solenoid, and that's a 50% duty cycle, that means it would be 50% on, 50% off. Sounds the same, but it's different. So a duty cycle is the amount of time something is on versus off. So I got 0% duty cycle, is never on. I got 100% duty cycle, is all the way on. It's on all the time. So again, pulse width, duty cycle, sounds the same, but they are different. A pulse width injector delivers fuel continuously with the engine speed. A 50% duty cycle means it stays fixed. It's always at a 50% duty cycle. Now let's look at this. Let's look at another signal. Not that one. Look at this one. Fixed digital pulse signal. This signal switch high and low in respect to time. A digital signal is created by a solid-state device. The on-off time referred to as duty cycle or dwell must remain fixed. Again, your duty cycle remains fixed. Hall effect sensors, optical sensors, digital mass airflow sensors, or map sensor. For instance, on a map sensor, as the speed increases, the frequency increases. Okay, but the duty cycle will be the same. It would be a 50% duty cycle. It wouldn't change. But the frequency would change with the increase in speed, just like on a map Hall effect optical sensor. My frequency increases, my signals increase that you see per second, but my duty cycle will remain fixed. Let's go to another one. Let's go to another one now. Look at this. My top signal, it's a digital signal also. My top signal is my RPM. 18x signal, which is RPM input, engine speed for the computer. As my frequency increases, my signal on off time increases. It's going from like 0 to 7 volts. The amplitude is going to stay the same. My frequency is going to change though as the speed increases. The bottom one, 3x signal, right, is my cam sensor signal input to the PCM. That's my engine position. That tells the PCM when to fire a particular coil for engine position. And RPM is my crank signal is my RPM signal. Again, as both these speeds increases, my frequency going to increase. Okay, but the duty cycle most likely will stay the same. Let me see. Anything else I want to show you?